Dear student, today we discuss the VIVA question based on experiment convex and concave lens. First, the examiner asked the question, what do you mean by lens? Lens is a transparent homogeneous medium bounded by at least one spherical surface. What are the kind of lenses? Lenses are of two kinds. One is the convex, another is concave. This is called converging lens. What we call it and this lens is called diverging lens. There are various kind of convex lenses are there: plano convex, double convex, concave convex. And three more concave lenses is also divided in three parts: plano concave, double concave, and convexo concave. And the examiner asks how the lenses are formed. Please see. We are using the two solid spheres. We cut it in like that. This is convex lens, which is thicker in middle and thin at the edges. This point is called optical center. What do you call it? Optical center. This is the first surface of the lens. Please remember it. Please pay attention about this point, that this is the first face which is facing the light. The center curvature of this is C1, and the second surface where the light emerges out, this is C2. And the radius of this is called radius of curvature. We are just measuring it from the optical center, right? R1, R2. And this is principal axis, right? How the concave lens is formed? We are using two solid spheres in which we are filling the material. Concave lens is thinner in the middle and thick at the edges, and same other points are there. Why we call it convex lens is the converging lens? Because it converges the light at one point. This point is called principal focus, and the distance between optical center and principal focus is called focal length. Why it is called diverging lens? Because it diverges the light which is coming parallel to the principal axis. This is principal focus and this is its focal length. Focal length of concave lens is always negative and focal length of convex lens is always positive, right of the optical center. In concave lens, see it. I give a best diagram for you. If the object at infinity, see it here. Image is formed at focus. If the object is beyond 2f, image is formed between f and 2f. If the object is at 2f, the image is formed at 2f. If the object between f and 2f, the image is formed beyond 2f. If the object is at focus, the image is formed at infinity. Image formed by it, real, inverted. This is highly diminished, this is diminished, the same size, this is magnified, and this is highly magnified. While concave lens is formed, what kind of image? It formed. Object is here, light coming parallel to principal axis, we meet it, we pass the light there, the image is formed. This is image. Image is virtual, erect, and diminished. How we can use convex lens as to form the image highly magnified? When the object is kept between focus and optical center, then the image is formed highly magnified, same side. What happened to the lenses? One more question is examiner can ask. We have a lens. The refractive index of the lens is mu. we imagine in a liquid whose refractive index is mu1. If mu is greater than mu1, please remember there is no change in the nature of the lens, focal length and power changes. Second point, if the refractive index of medium and lenses are same, then lens become invisible. It is behaving like a plain glass plate. Third, if mu is less than mu1, the nature of the lens gets changed. Concave lens behaving like a concave and concave lens behaving like a convex lens. Right? First very important question arises, what do you mean by parallax and how we are removing the parallax? Right, sit here. The image which is formed, this is object pin, right? Object pin, image, this is image pin. Object image is formed like this, right? When we just moving our eyes like this, if the images are going like this is parallax. How we remove it? By changing the distance between the object pin with the lens. If the image formed like this and we are moving our head, and with our head the image is moving like this is the removal of the parallax. This is the exact point that which we can calculate at that point. Right? So these are basically some questions which I discussed with you. Thank you very much.